Okay, so it's now your chance to try this here. So you're going to use the binomial probability formula to answer these three questions. Now, I have to say this last question's a little tricky. The wording is a little tricky. So do your best on it. See how you do. So you can pause the video, and then when you're finished, you can start up, and then we'll go through these. Okay, so let's see how you did on this. Okay, so in a particular county, 45% of the people are in favor of a new tax law. If 25 people are selected at random, what's the probability? Exactly 12 of those sampled favor the law. Okay, so in this case, the success here, let X equal number that favor the law. Okay, that's the success because I want to find the probability that 12 of them favor the law. Okay, so our N here is the number of trials. So each person you select for the sample is a trial. So N is 25. The P is the number of people that favor the law. And in this case, it is the percentage they give me, 45%. Q is that they don't favor the law, 1 minus 45, which is 55%. And I want to find here the probability that exactly 12 favor the law. Exactly 12 favor the law. Okay, so using the binomial probability formula, out of 25, choose 12 that favor the law. The probability they favor the law raised to the 12. The probability they don't favor the law raised to the number that I don't want to favor the law, which is 13. 25 minus 12. Okay, and so let's see what we get. So 25, choose 12 times 0.45 to the 12 times 0.55 to the 13. And I get 0.1511. And that is the probability that exactly 12 favor the law. So let's try the next one now. A particular store, at a particular store, 15% of the shipments arrive later than scheduled. If 35 shipments are expected, what's the probability that exactly 30 of them arrive on schedule? So I want to find the probability that 30 of them arrive on schedule. So we're going to let X equal number that arrive on schedule. Okay. And so the number of trials, each shipment is a trial. There's 35 trials. Okay, now what's the P? Is the P the 15%? And actually, the 15% is the number that arrive later than schedule, but my success is they arrive on schedule. So they actually gave us Q in this case, the 15%. So we have to mind our P's and Q's, right? And the number that arrive on schedule is 0.85. Okay, so then the probability that X is equal to 30, I want 30 to arrive on schedule, is out of 35, choose 30 to arrive on schedule. The probability it arrives on schedule raised to the number that I want to arrive on schedule. The probability it doesn't arrive on schedule raised to the number of failures I want. 5 of them that don't arrive on schedule. Okay, and then I'm going to get, let's see, 35, choose 30 times 0.85 to the 30th times 0.15 to the 5th. And I get, it looks like 0.1881. And that would be the probability that 30 of them arrive, exactly 30 arrive on schedule. Okay, so now this one's a little tricky, and I think it's in the wording here. It says 1 out of every 50 compact discs produced by a certain company are defective, and will not record properly. What is the probability that a pack of 50 will have 2 defective discs? Okay, so it's not giving me any percentage here, so it's giving me what I need to find the probability of a success. Okay, and in this case, let x equal, so there's a pack of, what's confusing is both of these, out of every 50, 1 is defective, right? 1 out of every 50 is defective, it says, and then it's a pack of 50. Okay, but those aren't talking about the same thing. So this is actually the number of trials. Each disc, either it's defective or it's not. It's defective or it's not. So on. And so there's 50 trials, and x is the number that are defective, because you want to find the probability that 2 are defective. So in this case, the success is that it's defective. So n is equal to 50. And then P here is the probability that it's defective. Well, 1 out of every 50 are defective. So I get 1 out of 50, which is 0.02. And so Q would be the probability that it's not defective, which would be 1 minus that, 0.98. Okay, so that's my P and Q. And then I want to find the probability that 2 of them, exactly 2, are defective. Okay, so what makes this tricky is just the 50 here and the 50 there and the wording. If I would have said, instead of 1 out of every 50 compact discs produced by a certain company are defective, if I would have said 2% of the disc are defective, what's the probability that a pack of 50 will have 2 defective discs? It probably would have been a lot easier. You would have known P is 0.02, Q is 0.98, so on. Okay, but that's what it's going to be there. So now, out of 50, we're going to choose 2 to be defective. The probability it's defective raised to the number of defective. The probability it's not defective raised to the number that are not defective. So, which would be, if I want 2 successes, I want 48 failures. Okay, so then 50, choose 2 times 0.02, 0.02 raised to the second times 0.98 raised to the 48. And what I get here is 0.1858. 0.1858. And that is going to be the probability that exactly 2 are defective. So that is the binomial probability formula. There's some more stuff that we're going to have to learn. And just kind of a quick heads up, like in this last one here, what if I had said that what's the probability that the number are defective are less than or equal to 2? Instead of exactly 2, I say less than or equal to 2. And the way you would do that is you would have to find the probability that x is equal to 0, x is equal to 1, and x is equal to 2. So you'd have to find 3 of them and add those probabilities together. So we're going to do problems like that in the second set of videos, as well as talk about the mean and standard deviation of a binomial distribution.